Hello, everyone. A very good evening. Welcome to our eighth webinar of Series 2. I am Jhumpa Mukherjee, Brand and Media Manager at Minimac Systems. Thanks for joining us today. We are aware of how important effective control systems are for plant reliability, but it is often forgotten when everything is running as it should be. But if the control system breaks down completely, it results in decrease in productivity. If you want to ensure appropriate maintenance, risk management, and reliability, stay tuned till the end as our experts today would discuss the topic turbine control system fluid reliability and maintenance. We have with us today Mr. Anshuman Agarwal, founder and managing director of Minimac Systems, and Mr. Yogesh Kumar, head of technical service department at Minimac Systems. The flow of the webinar will be presentation by our experts, followed by AMA session, that is Ask Me Anything session. Before we proceed, I would like to remind you all to drop your questions and queries in Q&A box, not in the chat box. There we might miss some important questions. So let's begin. Over to you, sir.
Thank you so much, Jhumpa. Thank you so much, audience, for joining out here. And this week, we are going to have celebrations and festivity all around the world because it's a very important festival going to come next week on Monday. That's Deepavali, Festival of Lights. So I'm sure with the conclusion of this webinar, we will go back to our vacations and holidays with good amount of knowledge, information. And when we come back after vacations, we have good amount of thought processes to rejuvenate ourselves in job and whatever we are doing. So today's topic of the presentation, that's one of the most important areas of a power plant, especially when it's a thermal based power plant. So turbines, which are the main equipment of a power plant for thermal turbines, it may be a gas turbine or it may be a steam turbine. So for controlling this turbine speed, for controlling the output of the turbine, there is a very important system known as the control system. And these control systems are responsible for proper synchronization, proper running of the turbine, because they decide the amount of flow of steam or gas into these turbines. And that's the reason why these become one of the most critical equipment of a thermal power plant. Now, these control systems normally work on high pressures, especially in the modern new age turbines. And because of they working at high pressures, at the same time, they working with the high temperature zones, that's the steam zone, it becomes very important to have a safety around these systems. So this is one of the reasons that these control systems in the new age turbines, they work on the special fire resistant fluids. So the entire control system, you can say, is like a hydraulic system operation. And for this hydraulic system operation, the fluid which is used is known as a control system fluid as per the nomenclature under its application. However, if we consider the properties of this fluid, it's most of the times, like 90% of the cases of modern turbines, this fluid is of fire resistant nature. And that's the reason why it is also known as a fire resistant fluid. The chemistry of this fluid in most of the cases is ester based chemistry. It can be a phosphate ester or a polyol ester. And that's why many times people also say that it's a phosphate ester fluid. So all these three names, one is control system fluid, which is a name based on its application. The second is fire resistant fluid, a name based on its property of fire resistance, and phosphate ester fluid or polyol ester fluid based on the chemistry of this fluid. There are three names all talking about the same application, the same entity, that is the fluid, which is used for the purpose of turbine control systems. So I'm sure whoever out of the audience have worked on these systems earlier as a part of maintenance or reliability groups, or maybe if you're a part of instrumentation group or production group, you would have sometime faced issues concerns related to this control system, and probably you would have faced some plant breakdowns because of this system. And that's one of the reasons why you have shown your interest to come down to this webinar and understand what are the issues related to these control systems. So before we get into the topic, let us understand whether we have seen these images in past during our professional lifespan. Like the first one is a membrane patch, which is testing the amount of varnish or amount of sludge deposit in your fluid. So did you come across such pictures earlier? Or probably if you have serviced some servo valve, could you find some of these brownish arrangements or brownish impacts on your servo valve surfaces? Did you ever find these sludgy deposits on your nozzles of the various valves or injectors? Many servo valves also have these filters, which are known as pencil filters or one through or one pass filter. So did you ever come across such clogged images of filters? And probably if you have come across of this, you would also know the amount of maintenance cost which would go in just to clean up these servo valve strainers or filters. Then these are some of the pictures of the acid filter materials which get degraded because of acid contamination in the fluid. And this is some picture of electrokinetic wear because of the low resistivity. And again, this happens in the nozzles of various components. So if yes, if that's the case, then yes, we have something in common, and it would certainly interest us to understand further on it. So before we go into the topic of FRF maintenance, it's very important for us to understand how the analysis report of FRF or control system oil is actually seen. So this is a fluid which has fire resistant properties, but as a matter of fact, it is being used as a hydraulic fluid. And just like all hydraulic fluids, again, this control system oil needs to have certain parameters in place. So the recommended properties which you normally test for a new batch of this oil, that is a phosphate ester or a fire resistant fluid. So these are the values that you would be interested in checking out. However, we have identified certain physiochemical properties which are extremely important for you to identify, to monitor, and to check out whether they are deviating from your benchmark values. So as we always say during our webinars, testing is just half the battle won. The second battle is to interpret the test results. And if you don't have benchmark values, if you don't understand the importance of these parameters, probably the testing part also goes in vain. So henceforth, let us plan our testing applications and testing programs in a manner that the values which are reported during the test are interpreted well. So for example, the first parameter, which is very important, let's go down bottom to top. The first parameter is the particle distribution, which, as the name suggests, it means how many solid particles are there in the fluid. We have the classification code ISO 4406, which can be used for that. Now, the standard values which are recommended by most of the fluid suppliers and OEMs, that's around 15, 12 or less than that. Now, this is the older version of ISO 4406, which has been mentioned on it, because most of the OEM manuals and most of the oil supplier manuals, they bear the same codification of ISO. So with these ISO levels, you can rest be assured that if you are maintaining such solid particulate levels in the fluid, then probably you are going to have a good life for this fire resistant fluid. The second property which is of importance out here is water content by weight. This property becomes very important because the fluid, the fire resistant fluid, has a typical tendency of attracting the moisture from the environment, because it's hygroscopic in nature. By hygroscopic nature, it means if it is subjected to a humid atmosphere, like if we have a fire resistant fluid tank and there is a header space on top of the tank, and if that header space is filled up of air, the normal atmospheric air, which normally has a humidity level between 70 to 80%, it is highly likely that this humidity from the headspace air will travel into the phosphate ester bulk inside the tank. And you won't believe it that this can happen on a very fast track basis. If you have doubts, what you could do is you could actually monitor the humidity level inside the tank by having a RH meter. And we have practically done it at multiple locations, multiple sites, and it has been found that higher humidity levels lead to higher water content in the fire resistant fluid, which actually proves out the theory behind it that yes, the fire resistant fluids or phosphate ester fluids, they are highly hygroscopic in nature and they do attract the moisture from its surroundings. The third parameter which being tested are electrical resistivity in the fluids. Now, this is important because this entire fluid is going to be used in servo valves whose functioning has got certain solenoid functioning in it. And that's the reason why electrical resistivity of the oil is extremely important, which needs to be on a higher side. So it needs to be beyond 50 mega ohm meter. The most important parameter which has come across a lot of professionals in the field is the neutralization number or the TAN number, TAN number. In fact, it's one of the nightmares for at least 25 plants around us who have been reporting very high, extremely high levels of total acid numbers, which easily give an opinion that acid number increase in phosphate esters is a common phenomenon. Now, there might be a thought that a lot of OEMs do provide certain fuller earth cartridges or certain absorbing cartridges, cell absorb cartridges, which have property to absorb any moisture content, which have property to absorb any acid content from the fluid, and that has been working since long. So even after the usage of these OEM fitted regeneration system or reconditioning system, why exactly is this happening? What is the reason that the parameters of particulate distribution or water content or even total acid number, why are they increasing? So of course, there is a limitation around the OEM provided reconditioning systems. They are not able to do their task as they were designed to. At the same time, there might be certain environmental reasons which probably have not been taken into consideration while that OEM fitted system was designed. So multiple reasons to why they are not working. But one most important conclusion, if these OEM fitted reconditioning systems are not doing that job of controlling the TAN values, of controlling the moisture and solid particulate values, something has to be done. And if not done, then probably you also would be landing and changing the entire fire resistant fluid of your bulk tank. And before that, of course, you might have to suffer some amount of production loss, or maybe a higher amount of production loss based on what is the total TAT which you take to rectify your problem in the control system. So the taking forward, the best conclusion from this slide would be to monitor your fire resistant fluid properties regularly for all these properties, and if not all, at least these 4 properties which have been mentioned here. So here's a poll question just to understand. Yeah,
Mr. Anshuman, I would like to interfere in between.
Please
that whatever we talked is very nice, and these are somewhat near to factory test conditions of a vehicle. But can you share some experience with the field trial when all the parameters were well within the limit, and we were facing issue of foaming because something else is also responsible. That is inappropriate selection of filters which destroyed the oil properties. Those properties are not mentioned here, but you can give that example. It will be nice for everyone.
Great. So thank you so much for reminding me on that. So apart from these four properties, if we see out here, there is a property called foaming characteristics or foaming tendency, which is something which has come up recently with a lot of users of this fluid, wherein all the other properties were probably intact or not much deviated, but foaming observed on the tank level was very, very high. High to an extent that the foaming levels or foaming height was approximately 1 foot, which is, I understand, very high as a practical professional for these systems. And because of foaming, the related problems in your pumps, in your entire system, the noisy application, hunting involves, all of these are related to foaming in the oil. Why this foaming happens? I remember we had a webinar a few weeks ago on foaming and air release values. It's very important to understand why this foaming happens and why this foaming is sustained in the fluid. So when you have a turbulence in any system, bubble formation would happen. You can't actually suppress the bubbles by some external force because it would lead to a lot of equipment accessory attachment to your system. So as a property, all these oils or lubricants or fluids, they have a property which is there because of an additive called the defoaming additive. And these defoaming additives ensure that even if there are bubble formation in your fluid, these bubbles won't sustain. By won't sustain, I mean they would suppress by themselves. But in certain fluids, like especially this fire resistant fluid, these bubbles sustain because of soapy nature ions in the fluid. And what are these soapy nature ions? These soapy nature ions are magnesium and calcium ions. So there would be a thought on why these ions are present in our phosphate ester fluid, because at the time of manufacturing, you might have got an elemental analysis of the entire fluid. There is no presence of any magnesium or calcium in that. At the same time, magnesium and calcium is not something which is used for the manufacturing of our system. That's the entire control system. So probably because of wear and tear of the system, magnesium and calcium can't add into your fluid. So what's the exact source of these ions or these metal ions into your fluid is a very important fact one should know. So a lot of you who has been having an experience of these fluids would understand the fact that there is a fuller earth cartridge which is provided by many OEMs since very long time now. And these OEMs are not small names, they're all big names. And during the last 50 years, the fuller earth cartridges has been used across a lot of industrial sectors. The purpose is to maintain a lower tan value or a lower acid value in the fluid. But unfortunately, over the last few years, it has been found that these fuller earth cartridges start releasing magnesium and calcium ions once the tan value starts build up inside that fluid. So while these fuller earth cartridges are completely unsuccessful in reducing your tan values, on the contrary, they are releasing magnesium and calcium ions into your fluid. And these magnesium and calcium ions start making it soapy in nature. By soapy in nature, I mean, I'll just give you an analogy. If we wash our hands with water, do we see any bubbles which sustain? No. Do we see any foam which sustains? No. But as soon as we start using a soap or a shampoo or a body wash, there is huge amount of bubble or foam or froth which is generated, and it sustains for long. So that sustenance is because of the magnesium and the calcium ions in water. Just imagine if the same level of magnesium and calcium is present in our fluid, certainly there would be some amount of impact of it. And that impact is known as foam formation. So once your oil catches the tendency to have this foaming, trust me, it's very difficult to reverse it back, because these magnesium ions are not easy to be removed. They are very stubborn. They form strong bonds with the chemistry of the fluid, and they won't remove so easily. There would be a huge amount of regeneration or reconditioning required to remove those magnesium and calcium ions. So it is always better to avoid them, and to avoid them, you need to control your acid numbers. And the second most important thing is, it's time to get away with those fuller earth cartridges. There are better technologies available in the market, so it's better to go ahead with the latest trends of technology. So Mr. Yogesh, I hope the kind of inputs you wanted in this field.
Yeah, thank you.
Great. So the next slide, we have a poll question. So I would like to request the admin to post the poll question on the screen. And I would request the audience to give their responses with the most honest opinion and most honest experience that they have had so far. At which stage the contamination is more prone to enter their machines, whether it's during the packing and transportation of the fluid, or at the storage of the fluid, that's the oil, or during the top up of the oil, or during normal operation wherein the wear and tear happens. Trust me, there is no correct answer to it. We are just doing a survey to understand what are the sources of various contaminations in the fluids. And this you can answer with respect to any of the fluids, any of the oils, industrial fluids that you have been using. Another few seconds before the admin withdraws the poll. Okay, so we have a mixed response out here. However, the poll is won by during oil top up, which is certainly a very important point, which has been made a very strong opinion of our learned audience, that yes, during oil top up, there are high chances of contamination getting added into the fluid. Now, let us elaborate on it. And maybe Mr. Yogesh, with your experience of maintenance, can you give me some of the examples of how oil top up led to immense amount of contamination getting added, especially if we talk about the control fluid oils, that's the FRF?
Yeah, sure. When we talk about the top up of the oil, the methodology we adapt is the prime most reason for contamination ingress. First point, when we use the oil transfer pump, the pump is stored in which area? Was it in the dust-free area, or it was kept on a shelf in the open area? That has to go inside the barrel. Next point, is that a dedicated oil pump for the control fluid, or the same pump is being used for different grades or different type of oil? Then the manhole or opening used for the oil top up. Are we opening the manhole, or is there dedicated a small plug from which we will fill the oil? Then the hose pipe used for the top up. These all points, if we take care, we can avoid the contamination ingress during oil top up.
That's true. And I can recall there have been cases where we could find lube oil traces in the control fluid. And probably that has happened because of a wrong pump usage. Probably the company was using the same oil pump for top up for all the oils that was present in their plant. So yeah, let us move forward from the source of contamination, and let's understand what are the contamination in the degradation process of a phosphate ester fluid. Just clear off this anonate. Yeah. So the first and foremost is the water contamination. And water contamination we shortly discussed in the previous slide. It is a highly prone contamination in phosphate ester because of the very hygroscopic nature of it. The source of water is not the fluid from inside, but actually the atmospheric humidity, which is in the tank headspace. So just take it as one of the most important contaminations because there is a degradation process associated with the addition of water inside or moisture inside the control fluid oil, that is FRF. And here, because of that, the acid formation starts increasing, or the acid formation process is accelerated. So because of these two, the water contamination and acid formation, the resistivity of the fluid also starts lowering. So the first three contaminants are quite related to each other. Because of water, you would find acid formation happening, and because of these two, the resistivity of the fluid will go down. Let's come to solid contamination. Solid particle contamination, first, it can happen during a top-up activity because the new fluid which you are adding, it might be having a huge amount of contamination because of storage, because of handling issues, because of its filling at the time of manufacturing. Apart from that, there is a wear and tear happening in the fluid very regularly. The wear and tear initially is on a lower level, but as you use the fluid more and more, and you have more of acid contamination in it, there would be corrosion type wear which will happen in the fluid and the systems. And because of that, the solid contamination increase is accelerated. And again, a relation out here with between the solid contamination and the acid formation is that when you have a higher amount of ferrous contamination, a higher amount of copper contamination in your fluid, unfortunately, the acid formation activity is super accelerated. So we have water contamination, which accelerates or rather takes part in the reaction where the phosphate ester bonds are broken. And these phosphate ester bonds are broken because of the H ion in the water contamination, that is H2O. And thereby it leads to formation of acids over multiple chain reactions. So that's water, what it does. The unfortunate thing is when water is present in the fluid along with copper, iron, and other metal contaminants, this entire process is accelerated. It finds a unique favorable condition around it. And that's because these metal ions start acting as catalysts towards that reaction. And this entire reaction of degradation of the control fluid, especially this phosphate ester, it's like a chain reaction, as I mentioned. So the products, the byproducts, even they start participating in the same reaction. They accelerate it further. And the reaction is so fast that in no time you would see that your acid increase rate has gone up like anything. So probably 1 week ago, you might have tested your oil having an acid value of mere 0.25 or 0.2, and you would have seen that it is in an alarming zone, but nothing to worry. But 1 week later on, you find that it's more than 0.8. And then you start blaming your lab people that probably they don't have the right reagents, they have all outdated chemicals, but the reality is something else. Probably your values of acid could not be contained because the action was not taken at the right time. Now this happens, why? Because when we go into the depth and detail of that analysis of that oil, the chain breakage reaction, we would see that the byproducts of this reaction start taking active participation in it, leading to a stage where strong acids like phosphoric acids have been produced. Of course, we are not going into much of depth of that chemistry. Maybe we'll keep for the next time. But you can take away from the slide that a solid particulate contamination in the fluid and water contamination presence in the fluid can lead to excessive formation of acids. And we have got live cases where the acid numbers have gone up to as high as 2.5. Now, this is unbelievable, I do understand, but there are certain unfortunate users where the acid numbers have gone beyond 2.5. And this, I'm not talking about the polyol esters, I'm talking about the phosphate esters, where the threshold value of the tan value is 0.2, nothing more than that. The next type of contamination impact is foaming. We discussed it already in the previous slide that foaming is happening because of magnesium and calcium ions, which are produced because of the fuller earth excessive usage. So it's a very important point here that you need to avoid fuller earth usage, in normal conditions, it's fine. But when tan values are high, please avoid the usage of fuller earth cartridges. Just isolate them, because that's not the solution. So in a way, I can say that fuller earth cartridges, which are meant to remove tan value or acid value from the oil, should not be used when acid numbers are high. So kind of a paradox, but that's the reality and truth of technology today. The final contamination effect, what we see in fuller earth, in the phosphate esters, is oxidation degradation. So because of the presence of oxygen, the degradation process which happens, that's the oxidation degradation. Again, the byproducts of this degradation is varnish products, sludge products, acid products, and many other byproducts which can accelerate further acid formation, further contaminations inside the fire resistant fluid. Now, you might be wondering that why we are talking about all of these, especially in fire resistant fluid. You might have been using mineral oil based hydraulic systems. You might be using it for last so many years. What special has happened with fire resistant fluid, and why these contaminations are attacking it so much? At the same time, few of you would be thinking that my fire resistant fluid is costing me millions of dollars, and then we are having it vulnerable to all of these contamination. So am I being fooled up by my lubricant supplier? Why have I bought something so costly and so difficult to maintain? So the answer is, when you buy a Ferrari, you need to take care of it, because you have spent a lot of dimes or a lot of dollars around it. The same is applicable to fire resistant fluid. It might sound like a luxury, but in reality and practicality, it's not. It's a necessity for your plants, because it's for your safety, for your plant safety, for your personal safety. So the requirement of fire resistant fluid in a thermal power plant is more of a safety requirement than a performance requirement, in my opinion. And then when it comes to safety, I'm sure none of you would like to actually deviate from your safety standards or compromise, and hence the usage of fire resistant fluids would never stop. So it's better to start learning how to maintain it better. Am I right, Mr. Yogesh?
Absolutely. And I would like to draw attention for a bump in front of your Ferrari. That is selection of wrong filtration mechanism. What we saw recently and experienced, that one substandard machine added lots of solid contamination in the oil. The rubber hose was not compatible for the oil. So entire hose, almost it was dissolved in the oil. Then zinc plated filter elements, they added additional zinc to the oil, which caused lot of foaming. Then the mild steel parts and pipelines used in the machine, they created havoc in the oil. And ultimate result was replacement of the oil, flushing of the system, top of a new oil.
That's very correct. So when we buy a Ferrari, we need to take care of it. We need to be very, very cautious with regards to the spare parts, the accessory systems, and whatever we use to maintain that Ferrari. It's all important. So unless you can't afford it, you don't buy a Ferrari. And that's the reason why not all of us have or own a Ferrari today. So the same thing is applicable for this fluid also. If we have it in our plant, it's our responsibility to maintain it in the best manner, with the complete responsibility around it and complete cautiousness around it, because one wrong move, one wrong selection of a part, a machinery which is going to work on this fluid, it might lead to a situation where we might lose the entire fluid. And trust me, this fluid is not just any other fluid. It's costing at least 100 times more than the normal cost of the normal fluids. So let us delve deep into the water contamination part, although we talked about it in brief. So what water contamination does to this fluid. So if we see this reaction where the phosphate ester chemical or the bond is there it is attacked by water, and in its surrounding, it's attacked by air and it has heated environment. So because of this, we are using block diagrams, but we are not using the chemistry around it right now, because there is something in place which we want to bring in future. So these phosphate ester bonds, those are broken, and those bonds are replaced with the H plus ions. Because of that, the phosphate ester gradually converts into phosphoric acid. We all know phosphoric acid is a very strong acid, and this acid can create havocs in your system. It will lead to corrosions. More than that, it would spoil the resistivity, the fluid lubrication properties, and it will spoil the functioning of the control system valves. The control system valves operation and its efficiency depends largely on how the phosphate ester is performing, how the control fluid is performing. It has been seen at a lot of plants where phosphate esters have been used. Once the control valve fails, there is a blame game which starts between the professionals. A lot of people start blaming the valve manufacturer. Few people start blaming the instrumentation people. Few start blaming the operations guys. Trust me, it's always the fluid which needs to be blamed, and the team who needs to take care of it certainly need to take a foot forward, start analyzing on what went wrong, why the valve has failed, why the system has not performed, and what's the traceable linkage between the phosphate ester fluid contamination and the failure at your place. There might be situations where you just want to hide the reason under the blanket, but trust me, this reason would come again and again in front of you. You can never get off it, because once your fluid is bad, once it has got degraded, there is no other alternative but to bring it back to its original shape. So, Mr. Yogesh, any anecdotes or incidences you would like to share wherein a valve failure happened because of this degradation and acid formation? What were the acid levels? Some case study which you can recall from your experience?
I can say that almost every plan has already faced this situation, replacement of move valve due to its sluggish operation or failure in operation. And when we dismantle those valves, we find micro pitting on the valve spool. Those micro pittings are due to this acid formation. And sometimes we see the silting effect on the spool corners. Those are because of high moisture content and mechanical impurity. Combined together, they form the silt. So in few plants, we have seen that move valve replacement was just taken as regular activity because they were not working on the root cause. And when they worked on it, in the past 3 years, they have not changed a single move valve. Power plants are available here like that.
That's great incidents which you have shared with the audience. So there are acid formation processes in the lubricant system, and we have discussed about how the acid formation happens. We have discussed about the foaming effect, how the foaming happens. So this is what the valve we are talking about, the servo valve. The servo valve has a typical sophisticated construction with fine tolerances, and the low resistivity values of the servo valve, this oil, the fire resistant fluid oil, that impacts electrokinetic wear in the servo valves. And in the initial slides, we showed some pictures of the electrokinetic wear, how you can identify them in the valve spools. So because of the lower resistivity of the oil, and which happens because of the contaminants like acids and moisture levels in the oil, these valves would completely fail to perform. Trust me. And in those circumstances, either you would experience hunting of these valves, choked up valves, valve sluggish behavior, and your control system not operating. So you might have an alarm at your DCS, and probably the entire turbine would have to be shut down for certain maintenance. So with these shutdowns, which are linked directly to the valve failures in case of a control system, it's not just the productivity time that you are losing. There's a very strong opinion from the climate change volunteers around. We need to have a better operational efficiency of the plants. And whenever you have a shutdown and post shutdown, when you do the maintenance of that shutdown applications, then you have to restart your plants. I believe you don't restart with the normal fuel, that is the steam, but you restart with the HSD. So, Mr. Yogesh, if you could give some opinion on how these post shutdown restarts can affect the environment in a way.
Yeah, sure. But before that, just one idea came in my mind just now, that if we check breakdown voltage for the transformer oil, then why don't we check for the FRF?
That's really a good point. Probably it's because the resistivity values, what we are seeing out here, or the conductivity values, they are very low. So probably that won't be able to detectable in these cases.
But we can think for this.
Maybe we can have a survey on it, because never we have found out any user doing a BDV test on a fire resistant fluid. We can certainly do some empirical studies and then probably give the audience some opinion on that. Yeah, so we were talking about the post shutdown restart of a thermal power plant. What's your opinion on that? Do you think that would affect the environment in a way?
This is affecting a lot in terms of the harmful gases generated, not only CO2 or CO, but NOx, SOx as well. And those are very harmful for the human being as well as for the ozone layer. So whenever we restart a unit, we need to fire HFO, HSD, and in huge quantity. They are in like 40-50 kL of the oil. So the amount of carbon footprint generated is huge. So due to just small negligence in the care of phosphate ester oil, we are leaving something very, very bad for the upcoming generation.
Okay. I'm a little confused out here. As we understand already, all these thermal power equipment, they are generating the scope 1 emission from our plants. And we all know that when you burn coal, the chimney will give out emissions and GHG emissions. So how is this post shutdown startup emission higher? What's the reason to that?
Yeah, rightly said. In normal operation, the combustion chemistry of a furnace is very good. But during the startup of the unit, the rich fuel is supplied to the furnace, and furnace is not exactly designed for long operation of that rich fuel. So unburned gases comes out, and those are not like gases coming out during regular operation. So a startup is very, very dangerous compared to normal operation.
So you mean to say a post shutdown startup, whatever equipment we are having at a power plant, they don't contain the GHG emissions with the same level of containment that a normal power plant system has?
Yes, of course.
Okay, that's something very interesting. And certainly this has to be linked to the carbon emissions, which we are associating with various thermal power plant operations. Because as a matter of fact, as a layman, if we start thinking that these startups would be how many, like 10, 20 in number in a year. So what would be the overall impact of these post shutdown startups? Do you think that would be good amount in terms of GHG emissions, which needs to be taken care of?
Yes, of course, because when ever turbine trips due to failure of governing system, then it takes some time to come back. So we cannot keep the boiler alive. So we have to go for post shutdown startup, and normally due to some reason like boiler tube leakage and other reason that cannot be avoided easily. But this is the thing which can be avoided with little effort.
So the overall GHG emission during the post-shutdown startup, if I ask you in terms of equivalence, how many days of normal operation of turbine can be said as equivalent to these post-shutdown startups?
Yeah, normally they consider is as 25 days of normal operation equivalent to one cold start of the boiler.
Oh my God, that's really very high. So audience, it's a very important fact here, which has been shared by Mr. Yogesh because of his experience. If you do a post-shutdown startup using HSD fuels or HFO fuels, just one startup is equivalent to 25 days of running of a normal power plant. So that's the equivalence with regards to the GHG emission that we do because of just one startup. Very important point here. Thank you so much, sir. So next we have the solid particulate contamination, because of which there would be fine tolerances in the valves, and when these increase, there would be good amount of choking in the spool movement, and because of the choking, the servo valves really won't perform. And it has been seen at various sites, 90% of the total solid contamination in the EHC fluids, these are below 4 micron in size. Now that's a very important fact here. I believe that's because there are a lot of fine particles in such systems. But I was just wondering, Mr. Yogesh, we already have that pencil filter, which is a one-pass filter in all the servo valves. Then what's the reason that these servo valves are failing, and why are they failing? Because of contaminant?
Yeah, just a few minutes back, I have mentioned that this is not failure because of one big particle, but it is due to continuous settlement of the particle on the spool to form a thick layer over the corners.
Right, right. And is it also because that these one-pass pencil filters inside these valves, they are of more than 50 micron, while we are assuming them to be of very fine nature, but because they are main line or full flow filter, they are not so fine that we are assuming them of.
See, these filters are very inferior component compared to the Moog valve, and no one would like to change the entire valve because of this small filter choking. So normally these are of very coarse in nature.
Right. And what do you think can happen because of the varnish? Because nowadays, a lot of such applications have been seeing varnish, sludge, and greasy kind of contaminants. So do you think the filter, the pencil filter, can get contaminated because of these sludgy particles or sludgy or gooey nature particles?
Varnish acts like we are walking on a very shiny surface and suddenly oil is spilled over the floor. So this makes the situation worse. And it accelerates the rate of deposition of solid impurities over the spool and fine clearances.
Right, because I can just recall I had a case where the customer was very, very confident with regards to the NAS value and ISO 4406 values. We also investigated and we found that the particulate levels were really very low, and the trend was being followed for a very long time. However, when we did the dismantling of these servo valves and the pencil filters came off, it was found that a very thick layer of varnish and sludge that was deposited on these servo valves. And because of these servo valves getting plugged up or clogged up because of the varnish and sludge, they could hardly perform. So although the fluid was having NAS4 level being maintained, which is super fine, the pencil filters were getting clogged because of the sludgy formation on the surface of the pencil filters. Okay, so next is aeration. Aeration in any system, any fluid system, can't be avoided. There would be air which would be produced, air bubbles would be there. So instead of these air bubbles getting sustained, they must self burst themselves and they should not form foam. And for this, you need to perform air release value tests and also foaming tendency value tests. We already discussed about foam formation and the reason why foam formation happens. So won't be repeating that again. And then we have these oxidation related degradations, which would lead to further formation of varnish. And as we mentioned here, blocking of filters and wall sticking related problems. So let us go on to the next slide and talk about how to reduce the total acid number by tricks. Tricks is a latest methodology because we talked about the contaminants. It's very important. Before we end this webinar today, we are already crossing time. So before we end this webinar today, we need to understand what are the solutions or remedies of answering the tan value increase in the fluid. So the TRIX technology, known as the tan reduction by ion exchange, this technology is the most successful one in the coming days. And this happens because of a absorption reaction and adsorption reaction on the resin surface. And these resins are highly sophisticated, well selected, and well formulated, cooked up resin based on your fire resistant fluid. So do not think that the resins would be same for all the problems around us. The fire resistant fluid manufacturer can be different. The fire resistant fluid problems can be different. The level of contamination would be different. The type of acid would be different. And hence, when the type of contaminations are different, we need to have customized solutions, tailor-made solutions or remedies for your problem. You can't just go to someone who does the entire solutioning with one product. And that's one of the most important takeaways from the slide, that even if you are going with any solution for tan reduction, it should never be a common solution. It should always be a customized solution for you and your plant. Maybe there are 2 tanks in your plant. One of the tanks will be resolved by resin number A, and the second tank would be resolved by resin number B. Although they have been working since the same age of the oil, they have been having the same environment around them. But we need to understand that the contamination buildup has happened in different ways. There are 2 patients going to the doctor with the same level of symptoms, but the doctor suggesting 2 different set of medicines to both the patients because of their body resistance, because of the type of virus or bacteria that has been the cause of their illness. And that's the way how these resins should be used. Resin technology is not something which is easy to understand. So you should always go with responsible solution providers and consultants whenever you are going for resin technologies. So how to sustain? If you have already done a solution with your fire resistant fluid, you already have the machineries to maintain the different various values. The most important fact here is to sustain, because the systems that the OEMs have provided us, we understood those are not the right systems for you. So the sustenance is important. And for that, we need to understand the depth of the contamination that we are having. So we all must be aware that moisture in the fluids is present in 3 forms. The first one is the dissolved form, the second is the free water, and the third is emulsified form. So when water is present in the free form, it's not difficult for us. Either it would settle at the base of the tank or it would go on the top of the tank based on the density difference between water and the fluid that we are using. Incidentally, in the case of phosphate ester, water is lighter than phosphate ester, so water would go up and phosphate ester would go down. So it's very easy to separate the free water from phosphate esters. But unfortunately, free water presence in phosphate esters is highly seen, because most of the moisture or water contamination in phosphate esters, it's present in the dissolved form. Now, dissolved form is very deceptive because the fluid would have the similar transparency as a new fluid. So whenever you are doing your visual inspections, you would probably never identify that there is some moisture presence in your fluid, and probably you would ignore the effects of water or moisture in your fluid. So thereby, the dissolved fluid is coming because of the hygroscopic nature of the fluid, which we learned a few slides ago. Now, what are the sources? We talked about those as well. The major source is the environment around it. What are the effects? I would not go much into the depth of it. You can see these pictures. Probably you would have seen it earlier as well in your plant. Some of the measurement tools, because of the shortage of time, I won't be dwelling upon these slides for long. Let us talk about the removal techniques of moisture. So there are 5 demarcated techniques for moisture separation from any fluid. Gravity separation, it's easy but time taking. Centrifugal separation, it's not easy when the difference of densities is not very high. Coalescing separation, yes, this is also a technology that depends upon density based separations. So for fire resistant fluids, it might not be effective. Absorbent separation and vacuum separation. So these are the technologies which are used very regularly with phosphate esters. For phosphate esters, the absorbent based separation is something which the OEMs have already provided you. But what's the catch? The absorbent base separation removes only free water. And 2 slides ago, we understood that free water presence in phosphate ester is unlikely a possibility. So if free water is not present in phosphate ester, I really don't conclude why the absorbent based technology should be used for moisture separation. So the entire usage of absorbent based separation for phosphate ester fluids is a questionable selection. But vacuum separation is something which has proven a very effective solution for separation of dissolved moisture from these fluids. How these operate, probably in some other webinar we would be talking about that. The most important thing what we can do is prevention is always better than cure. So in the previous slides, we talked about how to separate moisture from the phosphate ester fluid. But in this slide, let's talk about how to avoid any moisture presence in these fluids. So on the left-hand side is a standard tank, and on the right-hand side is the suggested accessory or the suggested attachment. We all know that the environment around our plants might be humid, and if we are operating on a coastal environment, the humidity would be higher. If there are tropical areas where rainfall is likely, then there would be even higher humidities. And of course, because of air pollution, the water vapor presence in the environment also increases. Now, all this water vapor, which is present in the environment in form of humidity, it comfortably enters the tank headspace through various sources. These sources might be man-made or maintenance professional made, and these sources might be OEM made. But let us not debate on what are these sources. Let us understand that there is humidity inside the tank. If someone of you does not believe it, just take a probe, insert it into the tank, and I'm sure you would find a value between 70 to 80% of humidity inside the headspace of your tank. This is a very simple activity you get at a very cheap price. The RH meters probably you would be having in your instruments department. You can check it out for yourself. And if you do find a high level of humidity, somewhere more than 50% inside the headspace, trust me, the solution, what we are suggesting right now, it's very important for you. So you need to have a capping system. A capping system is a well-known system for everyone, for any lubrication system. So you need to have a capping system on the headspace of your tank. And even better if you can have a capping system which is super dry. By super dry, you need to have a separate drying system, a separate drying attachment to the air, because your instrument air, which is running across the plant, it still might have a very high dew point. So it's better to have a separate localized drying system for this system, for this control system. And even better if you can have oxygen-free air to go inside, because as we learned earlier, even oxidation is a quite prone degradation process for these fluids. So having inert gas blanketing, a dry inert gas blanketing system is the solution which you need to have. And of course, if you can implement it, you can bring down the humidity levels by a large margin. And you won't believe, we have seen at multiple plants that just by the usage of these tank headspace dehumidifier or blanketing systems, the moisture level have been well in control. I have one instance from a steel plant in India where, as a process for steel, I understand they do have nitrogen lines all around the steel plant. And what they have done is they have a captive power plant adjacent to the steel plant. So they have created a special blanketing line or a nitrogen supply line till the tanks of these control systems. And since last 5 years, you won't believe their moisture level inside that control system oil has not gone beyond 100 ppm. And 100 ppm for a hygroscopic oil is extremely important and a very extremely unbelievable level. So this is what this kind of a system can do. It can do wonders for you. So the impact of the fire resistant fluids is that once they start degrading, the degradation process will initiate valve failures. Because of valve failures, there would be sluggish behavior of governing system. Because of that, there would be unplanned shutdowns, power loss, and loss of revenue. At the same time, today we got a very important takeaway from Mr. Yogesh, that there would be post shutdowns, there would be startups, and those startups would be highly inefficient in terms of the combustion of the fuel. And that inefficient combustion of fuel would lead to a very high level of carbon emission in our dear environment. So Minimac has a solution for you. It has a machine which can perform various tasks. First, it can perform the task of solid particulate contamination removal. Second, it can perform the low vacuum dehydration, and low vacuum dehydration can control your moisture levels. And third, it can have total acid number reduction systems using the right configuration of resins. But at the most important fact, these systems have a nitrogen blanketing system, which can ensure that there is no moisture ingress or no hygroscopic ingress of moisture into the fluid that you are using. So we firmly believe prevention is better than cure, and that's very applicable to your fire resistant fluid contamination control. So this is the system which we were talking about, and this is the blanketing system. It has multiple stages in it, and those ensure that you have a smooth, dry, and oxygen-free supply of nitrogen or dry inert gas into the headspace of your systems. So with this, the benefits would be extending of oil life, reduction in TAN values, increase reliability of governing systems, eliminate any oil changes, extend the life of your servo valves. Quite good system, a quite good solution. And here we have a poll question before we end the presentation. So maybe the admin can post this poll question so that we can take the response of our audience. Just few seconds, admin, so that we can jump into the Q&A round of this webinar. 5 seconds more, we can collect the response and end the poll. So we have moisture contaminant as one of the most important contaminants, that really very important, that the point the audience has made. And I'm very glad that you have started identifying it as one of the most troublesome contaminants in your fluid. And at the same time, I can see that a lot of our audience talks about sludge and varnish as well. Thank you so much for giving your response. Thank you so much for being a part of this webinar presentation. We had few more slides, but let us skip them and go into the most important session of this webinar. Most of you would be awaiting that. That's the Ask Me Anything session. Thank you so much from my side. Over to you, Jhumpa.
Yeah, that was a great presentation full of important information, best practices, and techniques. If you want any details of our services and offerings, please contact us on the email ID mentioned here, and you can also visit our website for more details. Before moving to the AMA session, I would like to announce the next webinar, how to increase overall plant efficiency by better lubrication management. On 8th December, please book your seat by clicking the link shared on the chat box. Moving on to the AMA session, requesting the experts to please switch on their cameras and unmute themselves. So let's take the first question. It's from Mr. Steve. What is the required ignition temperature for FRF?
So for FRF, I would not say it's a required temperature, but it's a temperature at which it might burn. And in normal operations of a plant, the FRF operational temperature certainly does not reach that level. It's FRF is being used for these applications because we don't want to have a fire situation at the end of this, because there are high temperature applications wherein this FRF is having in its vicinity because of the steam circulation in the vicinity. So we don't want to have that situation where because of that high temperature in the vicinity, the oil catches fire. So as a matter of fact, the ignition temperatures of the fire resistant fluids, they're much higher as compared to the mineral based fluids. That's the reason why these are applicable. In my opinion, there is around 300, 400 degrees centigrade where these ignition temperatures are there, rather at which they will start catching fire. And that is what is avoided. Am I right, Mr. Yogesh?
Absolutely right. And why we use FRF, there is a very small history.
Yeah.
Initially, the control valves and stop valve were part of the turbine casing.
Yeah.
When few incidents happened or where the unit caught fire, then two different thoughts. One was LMZ and one was KWU. What KWU did, they started using FRF. And LMZ, what they did, they shifted the control valve and stop valve away from the turbine. So nowadays in modern turbine, we find both control valves are away and we are using FRF. So now we are double safe.
Okay, great. Great history.
Okay, so the next question is from Mr. Farhan. It is found for the multi-stage steam turbine, water gets mixed with oil, and we as a maintenance used to remove that water content in the oil tank by the help of portable centrifuge pump. Thus, by doing this method, it doesn't affect turbine control system and efficiency of that oil. Should we take action immediately to replace oil, but replacing completely the cost increases?
Replacement is something is out of question. Certainly don't think about it. And all the oils, unless and until they are super highly degraded because of malpractices, we don't need to replace the fluids first of all. The reason why the moisture would be still present in your fluid, even after the usage of centrifugal, not pump, but centrifugal purification or separation systems, I would say. So these centrifugal systems can remove only free water content from the fluid. These are helpful mostly in case of steam turbine lube oil system and not in case of control fluid system. So both the tanks, as Mr. Yogesh suggested, in the modern turbines, both the tanks are separate. One tank is for lubrication purpose and one tank is for the control system purpose. So while we are doing the maintenance of the lubrication system, the chances of free water entering it into the lubrication system is high because they have the cooler system where the leakages can happen. We have the steam gland seal failures which can happen. So all of these are sources of free water. And see, whenever you are giving a solutioning, you need to understand for what are you going to give the solution for. So when we are having free water content in the lubrication system, centrifugal systems, coalescer systems, or gravity separation systems, these are all highly applicable and used across. But while we are talking about control systems, we certainly discussed during the webinar that these do not have free water content. And that's the reason why we need to move beyond centrifugal purifiers and certainly avoid them. And we need to go for something which is more suitable for this kind of a system, because we have all understood during COVID times, not all viruses are same. And that's the reason why you need to have different antidotes for different viruses, different antibiotics for different bacteria. And the same thing is applicable out here. When you are doing a remedy for contamination, you need to understand what type of contamination, what variant of contamination is present. Unless you do that analysis, probably your remedy won't be correct.
Mr. Anshuman nicely explained it. One small point I want to add, that OEM provides centrifuge with their package because they feel that it is sufficient to handle the moisture. Very good. They are very correct because they test it in the factory when oil is very new, and oil has tendency to leave the moisture away from it. Yeah. But in due course of operation, this property goes down after 5 years or 10 years of operation. Now oil has tendency to dissolve moisture in it. So now the role of centrifuge is obsolete.
Great.
Now we need something which can work beyond the level of centrifuge.
Great point. And in fact, there is a parameter which you can test, which is known as the demulsibility parameter for the lubricant oils. And practically, you won't believe, we have done it at our end with multiple 5-year-old lubricants, 10-year-old lubricants, in fact, with 1-year-old lubricants. And we found that in 1-year-old lubricants, the demulsibility factor had gone down drastically. And that was the reason why the water which was getting added into the lubrication oil, it was not present in free form. It was not able to separate it itself outside of the oil, neither it could settle down. So it was present in the emulsified form because the demulsibility additive had got completely exhausted. Yeah. Over to you, Jhumpa, for the next question.
Yeah. The next question is, will the use of desiccant breathers work well in managing moisture in FRF?
Yes, till an extent that these desiccant breathers are having that desiccant breather content in it. Many times we do adopt these breathers, but we don't maintain them regularly. We don't replenish them or regenerate them. And what happens as a result? These are not doing or performing the task they are meant to. So it's very important to have certain accessories to perform, but at the same time, we need to check what are they doing exactly.
Great. Okay. So the next question is there any problem if the moisture content is maintained as low as, say, 100 ppm for this oil?
Of course, if you can maintain 100 ppm, trust me, you have the best condition that you have done, but you need to also monitor it regularly. Many times it happens that our monitoring methodology is intermittent, and intermittent to an extent that we measure it once in 6 months or once in a year. That's not the right way of doing it. Let us have a much more disciplined way of monitoring our fluid. And that disciplined way means let us monitor it on a monthly basis at least. And then if we follow a trend, we check, yes, if our moisture levels are below 100 ppm. And again, let us be very vigilant on how are we going to test it. Are we doing the test with the right methodology? Are the equipment that we are using for testing the most calibrated equipment? And if then the results are favorable below 100 ppm, certainly we need not worry about it.
But Mr. Anshuman, one more discipline is required.
Yeah.
That is how we are removing the moisture. To maintain 100 ppm, if we simply boil the oil at 150 degree to remove the moisture is not the method. So by which method, what is the maximum temperature we are going to achieve so that oil will not get oxidized? So right. we have to understand the methodology as well.
Well said. Well said. Yes, that is very correct. We need not become so aggressive in our approach to achieve the KPIs that we forget the right track of it and choose the wrong methodologies, which might completely overturn our decision and come out to be much more drastic effect on the oil.
Okay,
Yeah.
let's move on. Which of the technologies is best suitable for removal of dissolved water from oil?
Certainly, it's the low vacuum dehydration once the oil is already having dissolved moisture content. But as I mentioned, we can avoid that dissolved moisture content in the fluid by having a dry nitrogen blanketing system for the tank head space. But yes, once the oil is already having the dissolved moisture content, because of various humidity reasons and other reasons of sources, the best technology available right now in the market is the low vacuum dehydration system.
Okay. Okay, so the next question is, chimney is mostly in the height of 280 meters. How does this contaminate air and will contaminate a FRF which is located almost ground level?
Rightly asked. The chimney height is not 280, but it is 275 meter. And and the gases coming out of the chimney, we are not blaming them to contaminate the FRF, but we are blaming them to contaminate the environment. To the ozone layer, to the human life, they are threat.
So I believe the audience is trying to understand what are the sources of solid particulate contamination in the FRF. Probably the person who's asking this question is more considerate about what are the sources. So my friend, it is the internal wear and tear which we are talking about. If trust me, if the chimney contamination starts entering into our hydraulic and lubrication systems, probably the plant won't even run more than a minute after that. So this chimney contamination, we are not worried for the lubrication system contamination, but as Mr. Yogesh mentioned, it's very harmful for the environmental contamination. For the lubrication system contamination, it's the surrounding dust which is around the system, and that surrounding dust is may or may not be because of the chimney, but more importantly, it is the internal wear and tear which is happening in a system because of motion of relative parts. That might be a translation motion, a translation rubbing of parts, or rotary relative motion between the parts, like the bearings or the valves or spools. So these are the cause of solid particulate contamination in the oils.
Okay, great. So the next question is, please advise us how to select the right moisture separation technique: gravity, centrifuge, coalescing, absorbent, vacuum, depending upon the application, criticality, and equipment.
I would suggest whenever it is based on application, it means what type of moisture or water is going to enter your system. So as I mentioned earlier, if it is free water, trust me, centrifuges and coalescer systems, these are the best known technologies. Of late, it has been seen that coalescer based technology is replacing the centrifugal technology because of its ease to operate, ease to maintain, less number of spare parts, and less number of headache, of course. So coalescer technology is best when it comes to free water separation. And as I mentioned earlier, low vacuum dehydration is best to remove the dissolved moisture content.
Yeah. Okay. Mr. Yogesh, you want to add something?
No, I think answered well.
Okay.
You have 7 more minutes to answer the balance questions.
Yeah. What roles does the nitrogen play in managing moisture presence?
That's really a good question. Now, nitrogen is an inert gas. And first of all, why we are using nitrogen? Because we are drawing the air from the atmosphere. Atmosphere has got multiple gases. First of all, we want to remove those active gases which are present in the atmosphere, like oxygen or carbon dioxide. So once we have removed them, all we are left with is nitrogen. So while we have to transfer a fluid inside the tank, it has to be something. And what better than nitrogen, which is completely inert in nature? So rest be assured that with nitrogen, we are not going to achieve any other form of degradation, because it is completely inert gas, not going to react. And as this air which is going inside the tank needs to be dry, so that's the reason why we first dry the air, then convert it into nitrogen by removing all the other gases, and that's the reason why nitrogen is used.
And one more point, that nitrogen has very good tendency to absorb moisture. It tries to get saturated with moisture very quickly.
Right. So again, it is of a
it is the
hygroscopic
best.
nature.
Yeah, of course, of course.
Right. And as it's of hygroscopic nature, which is a stronger hygroscopicness as compared to the FRF or phosphate ester fluid. So probably the moisture which is on the surface of phosphate ester fluid would again be picked up by the nitrogen which is passing through.
Yeah, rightly said.
Yeah.
Okay. So the next question is there any oil cooling system in vacuum dehydration unit?
Condensing systems are utilized because when you have these vacuum dehydrations, so the output of these vacuum pumps, those would have wet air, and that wet air needs to be condensed, and then it needs to be thrown into the atmosphere. So
Mr. Anshuman, I think he's asking about cooling system. If we are increasing the temperature of the oil during the dehydration process,
right,
if we don't elevate the temperature at that level, when we require any external cooling.
Right.
Yeah.
That's correct. So as these vacuum dehydration systems work on vacuum-based principle of separation of moisture, there is a physics around it. In fact, there is an entire video on YouTube, which is kind of a viral video. So I think it is already posted on the chat box. So you can check out that video on how this vacuum dehydration system works. Trust me, the heating which is involved in this vacuum dehydration process, it does not at all cross the threshold value of heating levels. So you can be assured there is no need of any cooling system because of the usage of these vacuum dehydration systems.
Okay. So Mr. Durga Prasad wants to know if there is any substitute to FRF oil.
Okay, so FRF is something which is important as per the application. And if we want to compromise on safety, probably all mineral grade oils are a substitute to FRF, because earlier in ancient times, in terms of technology, there were mineral oils being used for the same application, and application wise there was literally no compromise. But as a matter of fact, when few plants started catching fire because of the vicinity to the heated areas of the turbine system, this two different, as history was explained by Mr. Yogesh, these actions were taken, and that's the reason why FRF is highly important for our applications. But in my knowledge, there is no other fluid which can replace the fire resistant fluid. Even if we have, although we have multiple types of FRF, we can have water-based fluids, we can have non-water based fluids. If it is a water-based, we call it as water glycol. If it is non-water based, we can go for phosphate esters, or we can go for polyol esters. So there are different chemistries which perform the same task of lubrication and motion hydraulics, as well as having fire resistant fluid properties. So fire resistant fluid itself is a big family of products, and probably if we have a webinar on various oils in future, maybe we can invite some veteran and stalwart from the lubricant industry. And just a suggestion to the organizers, maybe we can have a panel discussion on how fire resistant fluids can be selected amongst the all types of fire resistant fluids which are available in the market.
Right. Okay. The next question is how to reduce the bubble formation in oil tank.
So some methodologies of reduction in bubble formation can be used, like the return line. All the return lines should not be hanging on the top of the tank. They need to dip down within the level of oil. There you can use the diffusers so that the turbulence is reduced when the oil is returning back to the tank. And then you can have baffle arrangements. So these are all those mechanical arrangements which are already provided by the OEMs of the systems. However, if you identify that some of your OEMs has missed out on these design aspects, you could always do the retrofitment and have it in place. And bubble formation, even if it is happening, you need not worry about it till the time the bubbles are sustaining themselves, thereby leading to formation of foams. So bubbles can suppress by themselves, they would get bursted, and that would not harm your system to much an extent. But sustained bubbles, because of soapy ions, as we mentioned, zinc, magnesium, and calcium, these are the three soapy ions. So you should avoid the sources of these soapy ions in the systems. One of the most important sources is the fuller earth cartridges. Just avoid them, just throw them off. You would find a lot of literature on these fuller earth cartridges usage, that they have been made obsolete around the world. However, in few geographies, we know that fuller earth cartridges are being used because of the legacy issues, because of the nostalgia issues, or stuck up lethargy issues. So these need to be removed off. No other solution. The second is avoid any zinc plated equipment around you. Many manufacturers who are not the standard ones, instead of offering you a stainless steel equipment, they start offering you zinc plated equipment. You might have a really opinion that these are all stainless steel equipment, but in practicality and in reality, they are all zinc plated. Start avoiding them. So this way you can avoid the presence of soapy ions in your fluid.
Okay, that was a great advice. Taking the last question of the evening.
Yeah.
So Mr. Mohammed Ismail wants to know, is it true that using nitrogen blanketing changes the oil color in due course?
Probably to the betterment of it, because if oil color has changed because of losing the transparency of oil, you would start finding your oil to be a pale yellow kind of oil for fire resistant fluid, because it has lost its transparency. Why it lost its transparency? Because tiny micro bubbles of water are present in it, and these tiny dissolved micro bubbles of water have changed the transparency of the fluid, and that's why it has become much more opaque. It has become pale yellow. After the usage of nitrogen blanketing systems, you would see that it is turning to betterment. The transparency is regaining, the color from pale yellow is turning to white or transparent. So that's always for better. However, if in certain cases you haven't used the correct methodology of generating this nitrogen, there have been situations where this system started adding carbon to the oil because of some wrong air which was the entry into the oil. And because of that wrong air going into the oil, if that itself is contaminated, probably you are adding more contamination because of the usage. So any solution what is being offered must be studied in depth. You need to check the right manufacturers of that system, and you need to avoid any such wrong practices or wrong usages around that system.
Okay, great. So the questions which are unanswered, we will release the FAQ document with all the answers which are asked during the session. And thanks for being a part of this webinar. I would like to thank our experts. So your feedback really matters to us. Please fill the survey form. See you next time. Bye-bye.
Thank you so much, Jhumpa. Thank you, audience.
Thank you.
Nice evening. And for you
Bye-bye.
starting the day, have a great day ahead.